this. Okay. So again, just to recap this word problem here, draw the coordinate plane like that. So the vertex is at the origin of the far left parabolic reflect or whispering dish. The focus is 1.5, the other was a 47. You have your equations, equation 1, equation 2. And then if you convert 6, 7 inches to feet, that's 2.79 feet. Sorry, divide by 2, then convert to feet. And then plug in for y and solve for x. You get x is about 1.3. That's a terrible handwriting. And then, of course, for part C, you can do 1.25, 4, plug in to the center general formula and solve for P. So, yeah. Go, Lucas.
Wait, so just make two separate forces.
Yes.
And they're 47 apart.
Correct.
Because they're
right
facing each other.
Right, correct.
And
well, you told to.
Yeah, and the focus and the 1.5 just P.
Right. That's P, yes, correct.
That would be the dishes.
Correct, right. Okay, so that's number 9. We're okay with that? Okay, cool. Anything else from the homework? Okay, so here's what we'll do today. Fine, one more. That's okay. And by the way, we're not gonna necessarily do the notes. We're gonna actually go over the homework. I'm gonna do some more prompts in the homework packet. That will kind of act as notes. And then I'll talk about what's in front of you guys, the review stuff that you guys just worked today. It looks good.
So wait, I think I left my parametric packet at home, but there
Yeah, okay. Which one? Here? Is that page 8?
Oh yeah, never mind. Page, yeah, page 8.
Okay.
So I got the 1B, I got like an exponential function, like not just like it approaches and then
It's not exponential. It'll be a power function.
Like 1/2 round 1.
yeah, that's exactly what I got. But then
Yeah, it's x plus 3 raised to the 6th power,
yeah, but
which
then,
kind of looks like a parabola, but it's not exactly. But
and then for part D, I
Mhm.
got like all like the inverse. Was the inverse?
no. What you want is you're asked to state the domain range for part A, sorry, for part B. That's all.
I got a really weird graph for part B.
Part B, you didn't get this graph?
No, I got that for part B, but for part D, I did not.
Well, part D is the whole thing. That's all.
Oh, okay.
Part D is graph we got on part C. You shift 3 left, and the end behavior, both arrows have to point up. For part E, you're staying the domain range from the graph of part B. B as in boy, should be that.
Okay.
Yeah. Yeah, because the parameter kind of defines it that way. Or just the nature of the equation, actually.
Wait, I found I eliminated the parameter really weird, but I don't know.
Do you substitute?
Yeah, I wrote y
Okay.
equals to. I wrote y equals to. No, I wrote t equals cube root of y.
You could do that, but then when you isolate y, you're gonna have to raise to 6th power.
Oh, I said that.
Yeah. Okay, got it. Other questions about this? You guys are okay with number 2? 2 is okay. How to
For identifying the, you just look at the coefficient.
yes. Yes. Yeah, and A is gonna be a parabola. It's kind of unique because doesn't quite you don't involve trig with that one. Well, for 2A, because when you substitute, you're gonna have just y x squared or whatever. Yeah. And these definitely circles coefficients are the same. C is an ellipse because you still have cosine sine with different coefficients. D because of all secant and tan. Yeah. Yeah. 3. I didn't sign page. Did I sign page 10? Okay, we're gonna work on that today. Okay. All right, so actually, let's go to the notes first. Just to do a couple things for the notes. Then I want to talk about the homework, and then I'll turn you guys loose. So we go back to the notes. I do want to look at this one part right here. Okay. Let's jump. Let's jump to the last page of the notes just to make sure you guys are comfortable writing things in parametric form. And then I'll kind of just point you to parts of the homework you could work on. So for example 6 on page 24, you're asked to change each conic from regular form to parametric. Regular form is when it's x and y. So rectangular. Rectangular involves x and y. Parametric involves t or theta. Okay. So we're asked to change each. Last page, page 24. Sorry, page 24, guys. Sorry, my apologies.
That's their homework.
Notes. I know I'm jumping around. My mind's all scrambled. So no, we want to do the notes, page 24. I just want to go to this last page because we didn't have enough time. So for part A, you kind of have some freedom here. You could actually say that equals t. It's actually fine. It's up to you actually. So there's actually infinite possibilities here.
Wouldn't that apply for all of these then?
No, not for the because when you're involving trig, no. You'll see why. We got total freedom to choose what we want for t. So -8 times x minus 5 equals t squared. When you move things around, you should get this. And of course, if I isolate y, so that would be a legitimate way of expressing an answer for that one. Looks good.
But the final answer always has to be in terms of x and y, like.
Correct.
Like x equals y.
Yep.
Yes.
Yep.
And when we're solving, and like when we're just solving like for the parametric equations, it always has to be y equals.
Correct.
Right.
And by the way, I could have said y equals t. I could have done that. But that's kind of a clean way of doing it. For part B, now we know it's a circle, obviously. So you can say x equals y equals. It should be pretty straightforward at this point. 5 what?
Yes.
Oh, wait. No, you're right. You're right. You're right. It is -5. You're correct. You're right. And 1. Okay. So that makes sense because if you isolate cosine theta x plus 5, isolate sine theta y minus 1, and do x squared plus y squared, and it should be fine. So x would equal that, y would equal that. Go and try C and D. I'll do it as well, and we'll compare.
This was in complex, we expanded.
Space studies. Yeah. Oh, yeah. I thought there's some real space. So this is Let's do 60. It's 16. No, this is still, like, 60. So this should be.
Wait, X is secant, Y is theta, I mean, secant Y is.
Correct, right.
Remember you, so you get to this part, we had to do some, you know, wait for you. Must make it. Yeah, I don't do that. So you get to this part. Oh, I know.
That's Thursday night.
Well,
Because you're like-
I'm just saying six, right? You're gonna give it for one, minus the minus the how much did you add to their side?
And I'm like,
So you just.
probably start on that.
Yeah, yeah.
Like, I'm not doing my one first.
I would have some. Those are big, it's not all. So it's plus 30, grow,
Oh, I haven't done.
grow, 29 minus 16, which is 30. Well, you didn't tell me, it's 13. No, you minus 4, because this is total 13. And
You're done your driving.
negative 16 plus 3 must be. No, because you have to do 5. You factor to the. Yeah, this was over here. Yeah. So you subtract the whole little bit point, so you add to this side too. I don't understand how we. Let's stop that. So we started with 25 now, right? Yeah. We end with plus 3 and minus 16 on this one, right? So you put it plus 3 minus 16, so you can go.
Wait, I
plus
don't have to
3
do this one?
minus
Oh,
16,
that's what I did.
and 20. So this is,
Okay, for me.
you have to do it to both sides.
Okay.
Negative 13. Negative 13. So they're gonna be adding. So I know you're so smart. That's how you get to the.
Fine.
Dude, we were wrong.
Plus one.
Yeah, that is. That's 44. It's 30, so 44. I don't know. That's what it's just people.
I always get scared. I'm like, what if they did it though?
Hey, that's on.
All right, I did figure out how to do parametric and Desmos. I'll show you guys in a moment how that's done. Before we do that, let's go through the stuff here. Okay, so for C and D, we'll go ahead and unfreeze that. That's an ellipse, clearly. X should equal 0, but you don't have to write 0. 2 root 2 cos theta. And Y should equal 1 plus 3 sine theta. You guys agree? Okay. Because you have to have 1 afterwards. Right? Because remember the y coordinate of the vertex or of the center is 1.
Do you have to simplify the radical?
Not really. Yeah. So that should be 1 because when you isolate y, you're gonna have to add 1.
Does it matter which one's sine and cosine?
Great question. Let's explore after I finish this. Let's talk about that. Okay, here now it's going the other way. So x will equal 4 plus 2 root 3 tangent theta. Y will equal 6 plus secant theta.
Wait, I thought X was secant and Y is tangent.
No, because y is positive here.
Whatever the partial was is.
Because secant squared minus tan squared is 1, and y squared is positive. Oh, you're right. I keep messing that up. Yes, you're correct. Thank you. Yeah. So now, how to do this in Desmos? How do I do this in Desmos? Okay. So what you do is you could say 2 square root 2 cosine. I'll just put t. You don't have to put theta, comma 1. You actually enter as an ordered pair, just so you know. Then Desmos just knows to ask for a range for t. So you put as an ordered pair. Let me clear my screen for a moment. And you could choose like, let's say we'll go from like, I don't know, negative 2 pi the 2 pi, and you get a circle. Sorry, is that no? Is that right? It's actually not a circle. It's actually truly an ellipse. Well, I know, right? That's more elliptical. It's because they're so close together, 2 root 2 and 3. That's the reason why it still looks like a circle. If I were to actually graph the true equation, sorry, the rectangular equation, this equation is true. X squared over 8. So x squared divided by 8 plus parentheses y minus 1 squared divided by 9. You see it overlaps it? It's the same thing. Yeah. So it's the same thing. So we will use the lockdown browser. I'll allow that for our test. Okay. I have to decide which the format of that test first. I haven't thought that far ahead. By the way, let me turn this off. What do you think happened here? Yeah. Or see the quarter circle or portion of circle. We'll talk more about that when we move into the polar coordinates or the polar unit after this, because that we have to do that kind of stuff. But you could do that. That's a possibility. So that's why you can graph that in Desmos. Again, in part D, I already showed you guys the answer, so you guys get there. Now, Kaden, to answer your question, what if I mix it up, right? What if I now let's go back to -2 pi to 2 pi. By the way, if you're ever kind of like not sure what's a good range, just do something like that. That's usually good enough. Now, what if I let's go back, let's make this 2. Let's turn this off. Okay, so clearly we have an ellipse. What if I make that sign? So it doesn't matter.
It doesn't matter.
It doesn't matter because it's still following the same identity.
Oh.
It doesn't matter. Right. So
If it would, but for the secant and tangent, that matters.
he's subtracting.
Because it's subtracting.
Correct. Right. Right. That does matter. Okay. One last thing I want to talk about. Okay, any questions on this? Okay, one last thing on the homework. So I'm not sending you homework over the weekend. I'm just gonna let you guys, do your own studying. But if you want to do extra practice, I would recommend you guys work on these problems. These are on the practice test, by the way. Problems like these. So really quickly, and actually, there's still one more word problem I want to talk about. I just remembered. So let's take a look at number 7. What do you think I should do about this one, guys? Number 7. How do I go about solving the system here? What I'll eliminate, yeah. So 2x squared minus 16x equals 0. Factor out 2x. You get 0 and 8. Okay. Then if you solve for y, ugh, does that be nasty? I think it is nasty. Yeah, I think I use quad form for that one, right? Is that factorable?
No.
Yeah, that's not fun. Or if I plug in 8, those still cancel, right? You still have to solve the same thing. Kind of gross. If I show you the answer key, what's that going to show me? I promise I won't do that to you guys. That will really make the test long. I don't want that. Yeah, see how nasty that got? You guys remember doing imaginary solutions? Yeah. And so obviously this means these don't intersect. These are this is a hyperbola and ellipse. And that's a possibility. There's a good chance that you could draw a hyperbola and ellipse is right in the middle of it and they never touch. And algebraically that's confirmed because when you solve for y, you got an imaginary solution. I'm not gonna do that to you guys. That's a little cruel. I won't do that to you guys. I don't know. I haven't decided yet what I'm gonna do. I haven't decided. Yeah. Anyhow,
Those solutions involved in imaginary numbers, not this is, right?
no.
No imaginary solution.
Well, you guys should know that. You guys could cover it. We are going to talk about complex numbers later in the year, but I don't care for that right now. I like the answers come out nice and predictable and neat. Predictable is good. Just so you know, there's other problems kind of like that. The other ones work out more nicely, but the practices I gave you guys have these kind of problems. Are you guys comfortable doing elimination, substitution, solving for X and Y? We're good. Okay, I don't need to waste your time with that. Okay, cool. So yeah, the rest of class just work. We still got another half hour or so. Yeah, just work on those practice tests. I'll give you guys more details on Monday. I don't know what I want to ask yet. I haven't decided that far ahead. So yeah.
If you want to.
And the answers are included, by the way, here. Yes.
Just like. How to do elimination.
I'll produce more.
Okay.
You have some right now.
Oh, yeah.
I'll produce more.
Or. You do it so you have minus per line.